Good day. Today we are going to demonstrate the integration of physics through four distinct prototypes developed throughout this semester. In the first stage, we do a hydraulic press that use the Pascal's principle to work. In the second one, a solar heater that use the thermodynamics. In the third stage, we do an homopolar motor that use the electromagnetism to work. And finally, an spectroscope that is used to know the chemical components of distant stars with the wavelength of the light.
Our first prototype is the hydraulic press. It is based on the Pascal's principle, which states that pressure applied to an enclosed fluid is transmitted undiminished to every part of the fluid and the walls of the container. By applying a small force on this small syringe, we generate a much larger force on the larger one. This is called mechanical advantage, and in the real world, this is how car braking systems and heavy industrial machinery operate.
Moving to thermodynamics, we have the solar heater. This device focuses on heat transfer, especially through radiation and the greenhouse effect. The black surface inside the collector acts as a black body, absorbing solar photons and converting them into thermal energy. This energy is then transferred to the water via conduction through the pipes. This is a direct application of sustainable technology, reducing the reliance on fossil fuels for domestic water heating.
Due to its high absorptibility, this surface maximizes the energy capture while minimizing reflection losses, which increasing the overall efficiency of the system. Once absorbed, this energy raises the temperature of the collector, and heat is transferred to the water mainly through conduction via metallic pipes, typically made of copper because it's a high thermal conductivity. In addition, convection plays an important role inside the fluid, as warm water rises and cooler water sinks, creating a natural circulation that helps distribute heat more efficiently throughout the system. The greenhouse effect within the collector fluid enhances heat retention. Shortwave solar radiation enters through the transparent cover but longer wavelengths. Infrared radiation emitted by the heated surface is partially trapped, reducing heat loss and increasing internal temperature. This process is analogous to atmospheric heat retention, where energy is absorbed and re-emitted slowly down to the rate at which heat escapes. From the thermodynamic perspective, the solar here is a clear application of the first law of the thermodynamics, which incoming solar energy is converted into thermal energy without being created or destroyed. The efficiency of this energy conversion depends on the factors such as insulation, collector designs, and temperature difference between the system and its surroundings. This direct application of sustainable technology reducing the reliance on fossil fuels for domestic water heating. In additional, it helps to lower the greenhouse gas emissions and promotes energy independence by using renewable, virtually unlimited energy resources like the sun.
For electromagnetism, we present the unipolar motor. This demonstrates the Lorentz force when the electric current from the battery flows through the wire in the presence of magnetic field from the medium magnet, a force is produced perpendicular to both. This created a constant torque.
So, with this, we can understand that with the interaction of the battery and the magnet, an electromagnetic field is created, and the energy of the battery passes throughout this invisible field and reach the coil, and that's why the coil rotates.
Finally, we explore physical objects with the spectroscope. This prototype uses a diffraction created to split light into its components' wavelengths. This is the result of diffraction, because different colors of light have different wavelengths. They bend at different angles when hitting the grating. Also, the spectroscopy is a vital modern science that is it allows astrophysicists to determine the chemical composition of star millions of light years away just by analyzing the light they emit.
With those four experiments, we seen how physics are actually behind almost everything we use. From the way we use fluid pressure to move heavy stuff, to catching solar energy for our homes, or even how a tiny motor spins using magnets. It all is related to the principles we studied this semester. Even the spectroscope shows that just by looking at light, we can understand what stars are made of. Basically, this project helps us to see how these laws work together to create the technology we have today. We hope these four experiments made those concepts a bit easier to visualize. Thanks for watching.